Bismillahirrahmanirrahim. Thermal properties of matter. So, here in this regard, first of all, let us discuss internal energy. Internal energy is the sum of the kinetic and potential energy of the molecules of a substance, and it depends on the temperature. That is, higher the temperature, more is the kinetic and potential energy of the molecules of a substance, and hence higher is its internal energy. It means whatever the heat you are providing to a body, that heat is changed in the form of kinetic and potential energy of the particles of that substance, and so it is increasing the internal energy of that body. Now, the next concept we are going to discuss the heat capacity. Please follow the definition that heat capacity is the heat energy required to raise the temperature of any mass of a substance through 1 Kelvin or 1 degree Celsius. Okay, so it means, for example, let us consider a body whose initial temperature is 20 degrees Celsius, and you are providing heat to that substance, and that after providing that heat, its temperature increases from 20 to 21 degrees Celsius. So 1 degree change in temperature has come around. So whatever the heat you have provided to raise this 1 degrees temperature is called the heat capacity. Now, here from the formula, you can see that the formula capital Q is equal to capital C into delta theta. This delta triangular sign which you can see, this triangular sign here is showing the change, and theta is representing the temperature, and delta theta is showing the increase in temperature or change in temperature, and it may be measured in Kelvin, capital K, or degree Celsius. You can see the sign of degree Celsius here. So degree Celsius sign shows that it is the temperature in degrees Celsius. Okay, now capital C is representing heat capacity. So the unit for heat capacity is joules per Kelvin or joules per degrees Celsius, whatever the unit you can use. Let us consider an example for heat capacity of a body. I am doing a numerical for you. So in the numerical, you can see that in a simple experiment, 100 grams of water requires 12,600 joules of the heat to raise the temperature from 30 degrees Celsius to 70 degree. Find the heat capacity of 100 grams of water. Now you can see that in this question, it is given the 100 grams of mass, but we are not going to find out specific heat capacity. We are only going to find out the heat capacity. So we are not taking mass into consideration. Now solution, we are given with heat supplied, which is capital Q, that is 12,600 joules, and the temperature rises from 30 to 70, so change in temperature is 40 degree. Now capital C, this capital C is representing the heat capacity, is equal to Q, the heat supplied, divided by delta theta. This is equal to 12,600 over 40 by calculating 315 joules per Kelvin, or joules per Kelvin can also be written like this. Okay, I hope this numerical is clear to you. Now the next concept which I am going to tell you, the specific heat capacity. Previously we were discussing the heat capacity. Now let us see that what is specific heat capacity. If we are using the word specific, it means we are specifying the mass. In the numerical which I have solved just now, you can see that there was 100 grams of water. So that 100 grams of water was not used in that numerical, because we were finding out the heat capacity only. But now in the case of the specific heat capacity, we are specifying the mass. So the specific heat capacity is the heat energy required to raise the temperature of 1 kg of a substance to 1 Kelvin. This 1 kg may be the unit mass or 1 gram, etc. But here we are taking for this formula, we will take 1 kg of substance to 1 Kelvin or 1 degree Celsius. That is capital Q capital Q, which is heat energy, is equal to mc delta theta. Now here we are using the small c and small m. Small m for mass and small c is representing the specific heat capacity. Now here you can see the formula that small c is equal to q over m delta theta. Now the unit for the specific heat capacity is joules per kg Kelvin or joules per kg degree Celsius. Now let us understand with the help of the example now how this can be used in a numerical. Now I am going to show you a numerical, so from this numerical you can better understand, I think so. In an electric heating coil, supplied 50 watt of power to a metal block of mass 0.60 kg and rises the temperature of the block from 15 degrees Celsius to 40 degrees Celsius in 90 seconds. Calculate the specific heat capacity of metal. What assumption did you make to arrive at this answer? First of all, let us consider this, that what assumption. Basically here assumption is this, which is according to the transfer of heat. We are assuming that all the heat supplied by the heater is absorbed by the metal and no heat is lost to the surroundings. Okay, so this assumption we have to make before solving this. Another thing, here you can see that in the numerical I have used 50 watt and 90 second. As I told you that power is equal to energy over time. This formula is already known to you, that power is energy over time. Here this formula we are using to find out the energy, that how much energy is supplied to the body. So heat supplied by the heater is P into T, power into time, that is 50 multiplied by 90, 4500 joules. Now heat absorbed by the block basically is equal to mc delta theta, because here Q is equal to mc delta theta. If we can say that it is the Q is equal to mc delta theta. Now that Q is calculated here 4500. So I am going to use this formula, PT is equal to mc delta theta. With the help of this formula we can find out C is equal to PT over m delta theta. Here PT basically you have already calculated, power into time 4500 divided by m is the mass which is given here 0.6 kg, and delta theta is the change in temperature which is 25 degrees Celsius. By calculating all this we got 300 joules. 300 joules per kg degree Celsius. This is the specific heat capacity of metal which is having 0.60 kg. So this is a specific metal. You must be aware that the specific heat capacity of a pure substance is a constant quantity. Okay, for a pure substance these values of specific heat capacity are always constant values. So in the next lecture inshallah we will discuss more topic. So for the questions answers you can use the comment section and ask me any question. I'll reply inshallah. Thank you.